Hello.
Hello, we can
Yes.
hear you.
Good. So can you see my slides?
Yes, I can see.
Good. So can we start now, Nariman? No.
I think Narima is not here right now, I guess.
Okay. So
Well,
just let me know. Just
Okay.
let me know when we
Just-
can start.
Sure, like more 1 minute, and then
No
we can
problem.
Okay.
Thank you.
How's it going, Salima? Let's talk meanwhile.
My students were so happy about your presentation yesterday.
My God,
They really enjoyed your workshop. Good job.
Was fun. Let's
Yeah.
do more. No worries. I'm happy. If they like it, I'm happy. So
Yeah.
they use in their life, in the IT world, is gonna be good for them, right?
Exactly.
I'm here to help. Okay. I'm curious now to see how it's gonna work on this.
Why?
Because, for example, Salima, the Firebase and NoSQL, I can use only in conjunction with Android Studio, or I can use in conjunction of another ID, for example.
They have for multiple. Yeah, you can do it for Flutter, for example. They have a lot of libraries for both Android, iOS, and web. Yeah.
Oh, that's.
But today I'm gonna present you in C#, which is not web, because it's common language of all our students. Yeah, and it's just got it was open source library, but now it became part of Firebase libraries. So they adopted this year.
Oh, that's gonna be really interesting.
Yeah. We're gonna build the real-time database in 30 minutes.
Cool.
Amazing. Okay. Yeah.
Good. More people are coming. So let me check. Now I'm excited to start. So for me, you can start. Is your stage. So we have many students. They're coming. My students are coming because I have class now. I told them to come here. So they should be here any minute.
On est là pour t'encourager, Salima.
Merci.
Bonjour Salima.
Bonjour Horia.
Ça va bien?
Très bien, merci.
On est là, Salima. On va suivre jusqu'au bout.
Thank you.
It's good. It's your stage, Salima. When you're ready.
Hello, Alex. How are you, Alex?
Good to see you, Horia. Long time. Oh, I have to enable my camera. Oh my God, I forgot my camera. Oh, sorry, Salima. I was talking to you with the camera off. I just realized it.
It's okay. It's okay.
Oh, we use it, right?
Salut Salima, salut Horia, salut Alex.
Ça va, my friends?
Right.
You're gonna still stay to the end for day?
Yes, j'ai envoyé certains de mes étudiants parce que je fais, tu sais, mes programmes de multi-chair application. Pour voir, parce que les bases de données les intéressent, c'est-à-dire comment on va créer ces bases de données pour le lier à notre client. OK?
Ouais.
C'est pourquoi je les ai tous encouragés à venir à ton...
Oh, merci. Tu vas voir, c'est facile, super facile.
Super.
Ouais, merci. Ce sera intéressant en tout cas.
Oui.
C'est pas la peine qu'on assiste si c'est facile.
Hein?
C'est pas la peine qu'on assiste si c'est facile.
Ben, c'est facile, bon.
Ouais. C'est taquin.
Bonjour.
Non, mais c'est vrai. Enfin, quand je parle, c'est facile par rapport aux bases de données existantes, ce qu'on a l'habitude d'utiliser. Le Firebase, c'est vraiment... c'est pas juste une base de données, c'est une solution
ou c'est un autre concept, carrément?
Non, c'est une plateforme de développement web et mobile et c'est pas juste database. Elle offre aussi d'autres outils comme l'authentification des utilisateurs, les logins, comme la gestion de la performance, comment faire les tests. C'est une solution complète de développement. C'est pas juste.
Allez, commence alors.
Alors, we can start, Alex?
Yes. Here we go.
Okay. So hello everyone and welcome to the 4th edition of Tech Week. I'm happy to present you today a Firebase workshop and NoSQL, an overview of NoSQL databases. So my name is Salima Hussain. I'm a teacher at LaSalle College. And before we start, I would like just to thank many people who made this event happen, like our director, Mrs. Nazha Alami, our coordinator, David Kadiu, and of course, Mrs. Nariman Mansour and her amazing team, INT. So all the students, they worked very hard to prepare and organize this event. So thank you. So I'm gonna start by, oops. Doesn't work, yeah. So first of all, we're going to start by an overview of the presentation. So it doesn't really matter which programming languages you are using and what kind of application you're building. Database skills, they are vital. So this is why in this presentation, we're going to start at the very beginning. First, I will start by introducing what is the difference between information, data, knowledge, and then why we use relational databases and what kind of problems you will likely run into when you use them. And this is going to introduce NoSQL databases. So we will see why they are so popular right now. And finally, I'm going to introduce Firebase, which is a platform for web and mobile development. And the lab practice would be how to create and use a real-time database of Firebase with C#. So if I ask you the question, what is data? Data are raw bits of information or pieces of information, and that has no context. So if I told you 4, 3, 5, so these numbers, they are data, but you wouldn't have learned anything, even if I would have given you data. So none of the above numbers have any meaning until they are given a context and processed into a usable form. So data by itself, it's not useful. To be useful, data needs to be given a context. And for example, if I told you that 4, 5, 3, 4 are customer reviews for a restaurant, then that would be information. So by adding a context to my data, I converted the data into information. And once we have put all the data into context, we can aggregate it, analyze it to produce knowledge. So the knowledge can be used to make decisions for our organization. And an information system must be able to put the data into context, to transform it into information, and provide the tools to aggregation and analysis in order to generate knowledge that can be used for decision making. So if I tell you why you use database or what's the problem that the database they are trying to solve. So when you are building an app, you're going to tell me that we need to store data, and we have this data can be anything like audio, images, videos, date and time, text format. It can be in any format. But having data is not the problem. The problem is what comes next. So why we should use a database? So we can use, if you say that just having data is a problem, I can tell you, you can use files and folders to save your data. So just having data is not good enough reason to need a database. And the problem is of using the file system So we have many problems. The first is the size of your data. So if your spreadsheet solution is good, so if your spreadsheet solution.
Salima, your mic is off. By mistake, I think you turned your mic off.
Okay, thank you. Yeah, because there was a noise. This is tried to mute everyone. Thank you. So the problem of using the file-based systems is the size of your data. So as I said, if your solution, spreadsheet solution, is good for hundreds of files, for hundreds of rows, what's going to happen if you have millions of rows? Okay, and you can say, okay, I can split my file in multiple files to store my files into organized folders, but then you're going to have a problem of speed. How you can find any information in these big files. So, and then we're going to have another problem, which is, whoops, which is easy of update. So what happens if we have two users who are trying to edit that shared spreadsheet file? Okay, how can you prevent users from overwriting someone else's changes? Accuracy. This is another problem. What kind of rules can prevent me from inserting wrong data in files? Nothing. If I put like insert a row where the column is missing, like email or a name of customers is missing, is that so important for you? How can you prevent that? Security. Usually you have, you need to share this file or this data with someone else. And just because you need to share it with someone, it's not a good enough reason to share it with anyone, because this data may have sensitive information. So how can we manage the security of data? How we make it secure? Redundancy. So what happens if you have the same data duplicated in my file? Let's say I have a file for product, okay, and we have the same product in multiple rows, but those rows don't have the same information. So the price is different, or the stock number is different. So what's gonna happen? Which one is the most accurate? So the redundancy of data may lead to inconsistency into problems or in conflicts, okay? And then finally, importance of your data. So what happens if you don't have any backup strategy and you lose your file? So you might lose like data of the work of 1 week or 1 month. So how data is important for you. So you want to protect it and from losing it. So to solve all these problems, databases were proposed and designed. But before I talk about databases, I just want to clarify that there is a difference between a database and a database management system. So the database management system is the software or the application that is used to manage your databases, to create and manage your databases, such as Oracle, SQL Server, MySQL, MongoDB. So we have multiple database management systems. And before I start explaining databases, I just want to give you an overview of the evolution of databases. So in early 60s, the storage that were used, it was direct access storage. And it's like file-based system, but the files, they were on a different medium, like magnetic tapes. And the first database management system was introduced in early 60s, and it was called integrated data store, but it became a standard in early 70s. In 1976, it's the introduction of the entity relational model, okay? And then in early 80s, the relational databases became mature, and they were used at the early 80s. We had multiple database management systems, and SQL became standard at that year. And then in early 90s, we had the evolution of our storage into client-server architecture, where we store our data and database in one server, and then we have multiple clients that try to request this data. And the need to develop SQL Server, it's because at that time there were new applications like ERP systems, web applications, data warehouses. So this is why the people, they think that they start thinking about evolving the storage. But it wasn't enough. So this is why in early 2000, we have the storage area network, which is we have one shared storage that is used by multiple nodes or multiple computers. And this is called cluster or SAN systems. And in 2005, it was the introduction of the first tablet. 2007 is the introduction of the first smartphone, and this becomes the beginning of the era of cloud systems and NoSQL databases. By 2050, who knows, maybe our devices, they becomes nanotechnologies, like we're going to have a nanoscale object that's going to be chips integrated in our brains, and all objects becomes connected together. Who knows? So relational databases, it's an organized collection of information, okay, related information. And in relational databases, data is stored in one or more tables. Each table, it has rows and columns. Each row is not free-form. It has a structure. This structure is defined by the columns. So every column has name and data type, and we can apply some kind of rules for each column to ensure data integrity. This is what we call a schema. So databases, relational databases use a schema to ensure data integrity. They have multiple constraints like primary key, foreign key, not null, unique, check. And like, let's say in this example, users, table of users, we can say that the name, it shouldn't be empty. So we apply not null constraint. For the ID, we want to have a unique ID that cannot be null. Then we apply a primary key constraint. This constraint prevents us from inserting wrong data. So if I try to insert a new row with the value of ID that already exists in my table, this will not happen. So the database management system will prevent me from inserting that wrong data. This is an example of 3 tables to just explain the relationship, how we build relationships in relational databases. So let's say I would like to build an app for that display the reviews of restaurants and take the reviews also from users. So for that, I need table of restaurant, table of users, and table of reviews. All of them, they should have primary key. Now, if I'd like to find what are the reviews that are related to one particular restaurant, then in this case, I need to add a restaurant ID as a column in the table review. And also, if I would like to know who's the user who applied or who did this review, then for each also review, I should have a value of a user ID. And this to make sure that the values of user ID or restaurant ID, they are consistent, so they are valid, we have to apply the constraint foreign key. So what is a foreign key? The foreign key should be a primary key in another table. And the purpose of doing foreign key first is to find the relationship between tables, and second is to prevent from entering wrong data. So if I try to insert a new row where restaurant ID do not exist in the table restaurant, or the user ID do not exist in the table users, this will not be possible. The database management system will prevent this kind of problems. So it's amazing. Relational databases, they solve all the problems of file-based systems. So how we can, I'm gonna give you an example. From one particular restaurant, we can grab all the reviews in the table review. thanks to our relationship or our foreign key column in table reviews. And I'm gonna get all the other rows that I want to display, the other columns that I want to display. Now, if I'm interested also in displaying the information of users who did those reviews, then thanks to the column user ID, I can grab all the information I need from the table users. And this in relational databases, it's made next thanks to join queries. So in one query, I can grab information from multiple tables. I'm gonna show you this app. So this is my app that I want to develop. It's a web application that's gonna display the reviews of all my restaurant. So here I have information from the table restaurant. I have information that I need from the table reviews and the information from table users. I'm gonna grab data from different tables and bring it in the same location on my web page. So to do that, it's so easy with one join query. So we're gonna say select star. It means all columns from table restaurant reviews and users where user restaurant ID is 102 because I'm interested in that particular restaurant. And then to link to find the related data in table users and table reviews, I have to say that every review dot restaurant ID should be equals to restaurant dot ID, and every review dot user ID should be equal to the table users dot ID. So this is how I gonna match the rows from table review, restaurant, and users. Now, the problem with join queries, if when you have like, this is easy, you have three tables, it looks easy and fine. But if you have hundreds of tables, then it's gonna hard to grab the information from all these different locations. So yes, it's gonna give you the result, but maybe the speed, it's not very fast, okay? And of course, I cannot talk about relational databases without mentioning normalization, database normalization, which is a process of organizing data according to some rules that have purpose to eliminate redundancy and consistency of our data. So we have three normal forms. The first normal form states that every table should have one primary column, and every column should have unique, like a single value. I cannot have multiple values stored in one column, so it should be atomic and single value. The second normal form, it applied when you have tables with where the primary key, it's a composed primary key. It means you have more than one column to represent your primary key. And in this case, we have to make sure that every column that is not part of the primary key depends on the whole primary key. So in this example, I'm giving you a table of events, and the primary key for this table is course ID and dates. Then we have other columns, for example, course title, room, capacity, and available. Then the available maybe places for that room. Now, for in this case, we see that the course title SQL fundamentals, okay, it's always the same for the same course ID. So when we have SQL 101, it's always the same title. That means that this column course title depends only on the course ID, because even if we change the dates, the value remains the same. So in this case, that course ID, it can be a candidate primary key for another table. And this is what we have to do to bring it in the second normal form. So this is not in the second normal form. To make it in the second normal form, we have to reorganize our data. So we're gonna extract the column title and course ID in a separate column that we're gonna call course. And I'm gonna, of course, define the course ID in the table event as a foreign key to make sure that we're gonna have always consistent data, or to ensure data integrity. So now it looks good. I don't have duplicated data. In the previous slide, if I go here, you see SQL fundamentals, it was duplicated. and I can, by mistake, I can enter wrong title, and then we have inconsistent information. But once it's normalized in the second normal form, the SQL fundamentals appears only once in the table course. Now, if I want to get that type, the title for my event, it's simple with a join query. So, however, my table is not in the third normal form. That state that every column that is not part of the primary key should depend directly from the primary key. Or in another way, I can say every column that is not part of the primary key, it cannot be a candidate, like there is no other columns that depends on it. Okay, so here we can see that the column capacity, it depends on the room. Okay, so whatever the event is, for the room 4A, it's always the same capacity, or the room 7B, always the same capacity. So in this case, the room ID, it's a key candidate, okay, for primary key of another table. And instead of duplicating capacity for every event, we're just gonna extract it in a separate table where we're gonna put room ID and capacity in that table room, for example. And for sure, we're gonna create the foreign key constraint to link the two tables. Now, thanks to the join query, we still can display the capacity of our room for every event, okay? So this is the normalization. The purpose of normalization is to extract our data. So we reorganize data from different tables to make sure that we don't have any redundancy, and this is gonna make our data always consistent, and also easy maintenance, easy updates. So for now, relational databases, they are amazing. But there is a problem with the relational databases. And the first problem is the schema. The schema that was proposed in relational databases to provide database strict rules at database level that prevent users from entering wrong data or duplicating data. These strict rules, they are hard to change. The problem is, so here, for example, when I create table, I give the table customer name. Customers is table of customers. I have column ID, first name, phone, location. I applied my constraint, so the ID is primary key, first name is not null, and the phone is unique. That's fine. Now, if I try to insert a new row, I just apply insert query where I have to respect all these columns that already exist in my schema. So I have to respect the type of data that for each column and also the constraints, okay? So here, for example, I'm inserting this new row, but if I try to insert another row with a new column that do not exist in my existing schema, this will not be allowed. What would be fine, because that's the purpose of using a schema anyway. So we use strict rules to prevent people from entering inconsistent information. But in this case, if your design, and it's really hard for beginners, believe me, it's very hard to find the best design of your database. Even if we apply it, thanks to the normalization rules, we can optimize our database. And we can say that our design is good, but sometimes you miss some fields. So in this case, if you want to add the last name column, then that would not be possible. Okay, so to solve this problem, the developers, what they should do, first alter the table to add a new column that is called last name. If I want this last name to don't be empty, okay, so I have to apply the constraint not null. But then I'm gonna have another problem. Why? Because when you add a new column, all the existing have null value by default. And we said that this column cannot be not null. We apply the constraint not null. So to solve this problem, we alter our table again. We remove the not null column, okay? The not null constraint, sorry. Then we have to update our table to insert values for every row. And finally, we can bring back this constraint not null, and insert our row. So there are some few steps that we have to do before we will be able to change our schema. So it's very hard to change your design or iterate your design when you have this strict schema. And a lot of developers don't like relational databases because it's not easy for them to change this schema. Second problem, and huge problem, it's these databases scale vertically. What that means, so when we insert rows in our table, when we insert data, this data will be inserted into rows, okay? And each table can be stored only on one machine. It cannot be spread on different machines. So when this our table grows and it reach our full size of the machine, the solution is to create it to a bigger server or a bigger machine. However, if the growth is too fast, then the migration process, this is gonna lead your database to crash. So the limitations, if I summary the limitations of our relational databases, we have a strict schema that's gonna make they make the life hard for developers who want to iterate on their design. And we have limited data growth and scalability because they scale vertically only. So this is why they are not good for big data. We have limited concurrent performance. So if we have multiple users that try to access simultaneously at the same time to that database, because of the lock-in mechanism that are applied on every table, when a user try to update this table or modify it, and this lock-in mechanism, it will stay or lock this table until the transaction it fails or succeeds. Because of that, it's not good for big big users. Okay, so if we have here an application, we have more users, then we can just decide to add more servers for our relational databases. But if our number of users are huge and exponential, in this case, your database will crash and your application will crash. So to avoid that, we have to think about move on NoSQL databases. What are NoSQL databases? NoSQL database, they were developed in the beginning as a response to web data and the need to process unstructured data and that need fast processing. The NoSQL model uses distributed database system, which is good for data growth, and that meaning that your data is spread on multiple computers. And in general, the NoSQL databases, they are better choice for large and unstructured data that are not possible with relational databases. And the term big data became an official term in 2005, which is also start the era of NoSQL databases and the cloud systems. So this is a summary of our main or the first NoSQL databases, because there are a lot, okay? And generally speaking, all these NoSQL databases, they don't use any structure like tables of relational database. Okay, they store data in different structures, like we have document based, column based, key value of Amazon, Cassandra, which is from Facebook, it's also column based. We have MongoDB, CouchDB, they are graph-based, document-based. The graph-based, it's a Neo4j, and so on. So they were just thinking of restructuring this data because the current structure and the current schema of the relational database just make it impossible to handle and to store all this big data. So, but one common thing of all these NoSQL databases, they are all schema-less. okay, which is good for our developers. So today, I'm gonna give you an overview of these NoSQL databases, but at the end, I will give you a demo on how to use Firebase. That I said, it's a platform of development. It offers many tools to develop web and mobile applications, and it offers two NoSQL databases. It has a real-time database that we're gonna use today. It's a key value structure. It uses key value structure to store the data. And we have a document-based database, which is the evolution of the real-time database, and it's called Cloud Firestore. So, but before that, I want to explain a little bit what is every kind of the NoSQL database. So let's start by the column family. So in column family database, data, like the table that we have in a relational database, here we have a collection that is similar to table. We call it a super column family. So it's a container of an ordered collection of rows. It's really important, the order. These rows, they are ordered. Why? To make the processing and the search very fast, okay? Now, each row, it's called a column family. It's not a row that is free, that has a strict schema to follow. No, it has a collection of columns, and these columns also, they are ordered, so they should be ordered. Okay, so the rows, they are ordered in the super column family, and the columns in each row, they are also ordered. Now, there is no schema that forces these individual rows to have all the columns, and each column is defined by three data. There is information. We need a key. Okay, we need a value that we store in that column, and a timestamp, because if we want to make sure this data is available, we have to duplicate the same row in multiple machines, so that if one of the machines fall down or crashes, we have duplicates. But we have to make sure that this duplicate is accurate. This is why we have to add a timestamp that just give us the date, the modification date of that data, okay? And I'm gonna give you examples of databases like Cassandra of Facebook, a Bigtable of Google, and HBase of Apache. They are using this kind of collection. Now, I give you more example what it looks like. So let's say in relational databases, we have table employees and table jobs. And these two tables, they are related with one foreign key, which is job ID. And it is linked to the primary key of the table jobs. Now, if we want to do it in Cassandra, for example, which is a database of Facebook, we have to use a super column family. So instead of creating a table, we're going to create a super column family. And every row, it should have a key that is unique. It's kind of similar to a primary key, okay? But every row, it is a collection of columns, okay? So in the first row, you see we have 4 columns. The second row, we have only 2 columns. The third, we have only 3 columns, and it's fine. So the rows, they can have different structure. They don't follow a schema. This is what's meaning schema-less. Second type, graph-based. And in this case, the database store data in a graph-like structure where the nodes represent the entities and the edges represent the relationship between those entities. So, and there is a unique identifier, of course, for every node and every edge. And an example of a database, it's Neo4j, which is developed in Java, but it's super fast, even if we have millions of nodes. And the purpose of this database is to focus on the relationship. They want to keep the relationship between their data. So there are some few cases where it's good database to apply. So key value This is like DynamoDB of Amazon, Firebase, which is our real-time database that we're gonna use today. So in this kind of database, NoSQL database, data is stored in a structure that is tree, and every node of this tree, it has key value. This is why we call it key value. And when you try to retrieve all the rows, kind of rows in relational databases, here you're gonna retrieve a map or a dictionary. Okay, every node you see, it has a primary, it's kind of primary key, which is a unique ID. And if you want to access to one particular node, then you have to give that ID to your query to provide the data that you want. And as you see, we don't have exactly the same key value pairs in every node. So for example, here we have name and text. Here we have name and photo URL. So all these nodes, they are schema-less. And they are using JSON objects, okay, for values, to store the values. So the value can be either JSON object, string, or blob. And the keys, they are string, of course. Document-based. So for this kind of NoSQL databases, it's a collection of documents. So database, it's a collection of documents that are JSON objects. And it started with CouchDB and MongoDB. They were the first document-based database. The difference is that those databases, when they were proposed at the beginning, their purpose is to organize document, not just data as we need. It's really document. You have PDF document, you have images, you have big files. We want to store files on the disk, and we want to be able to find those files very fast. So it's the purpose is to store files. This is why we call it document-based database. In MongoDB, for example, they are using a binary JSON object that is called BSON, and this is a binary document. Okay, in JSON the values, they are as a string, but in MongoDB they are binary. Now, so the document, they are all independent of each other. They are schema free, flexible to add or modify any documents. And document, they are stored in collections. Okay, we can see a collection like a folder, and yeah, we can, and inside the document, the data may be a key value pair, like, because like like here, so it's a key value pair. But in MongoDB, the huge binary files, it's not key value, because I said here that the value can be a blob. So this is the case of MongoDB. So you have a key, but then your value is going to be a huge document in binary formats. And I'm going to explain in detail documents in the next slides, because Cloud Firestore of Firebase, it's a document-based database. Now, you're going to say, oh, you present different types of NoSQL databases. Which one we should use? You have so many, and they are all good. Yes, so you're right. And this is why I'm presenting the CAP theorem, which is also called Brewer's theorem, because he proposed this theorem in July 2000. So it states that a distributed data store, like database, cannot simultaneously or at the same time ensure or offer more than two guarantees. What are these guarantees? Availability, which is so the system can continue to operate as expected even in the presence of node failure. The second guarantee is partition tolerance. So the system can continue to operate despite network failure. So if the communication between nodes is not good, delayed, or even dropped, they should be available. Okay, the system should continue to operate and serve our users. And the third guarantee is that all clients, they can see the current data regardless of the update or deletes. So to make sure that they all see the same value, we don't have inconsistent data, okay? And our databases, they don't offer the same guarantees. That's the difference between MongoDB, Firebase, or Neo4j, for example. So this is NoSQL databases. Most of them, like DynamoDB, CouchDB, Firebase, Cassandra, they focus on the availability and the partition tolerance. For MongoDB, HBase, and HBase, they focus on consistency and partition tolerance. And Neo4j, which is the only NoSQL database that focus on availability and consistency. Why? Because it's inspired from the relational databases, and all the relational databases, all the SQL databases, like Oracle, SQL Server, MySQL, they all offer only availability and consistency. Now let's go back to document-based database because our Cloud Firestore, it's use that structure. So in this kind of database, as I said, instead of having tables, now we can see it as a collection, okay? A collection of JSON objects. And this object, they can have multiple fields. Like here we have ID, name, and phone. Let's say this is a collection of restaurant. I go back to my previous example. Okay, if I take the example of restaurant again, so we're gonna have a collection of restaurant where every object, it has all the fields I need for my restaurant. But the good thing here, it's a schema-less. So I can add at any time a new field or new like category, for example, of restaurant, and I don't have to worry about my existing restaurants. Okay, so you can easily change your schema because there is no schema. You can easily change the description of your documents or your restaurants. Now, so I have restaurant. If I want to have the reviews of my restaurant, that would be another collection. So I have collection of restaurant and a collection of reviews. And for sure, you need to know what are the reviews of what particular restaurant. So this is why we need the key, the restaurant ID, which is a unique key for every object or every document. I have to put it for every review. But then like to find all the reviews of one particular restaurant, I have to just find in the second collection all the objects that have that key. The problem here is that there is no join queries. I cannot do that in one query, okay? So join queries, they are not possible in NoSQL database, which is good because it's gonna speed up the process of getting the data. Now, how I can do that? Okay, so for that particular example, we can say it's fine. So at the beginning, I can just on my web page show all the list of restaurants, and I grab all this data from one collection restaurant. But then when the user select one particular restaurant, I can grab all the reviews from the table, from the collection of reviews. So for that example, it's fine. How about the users? Where is the information about users? So if I would like to display the profile picture, the name, and the location, I need another collection for users. So let's say I have a collection of users now, and I have a collection of reviews. If I just add the user ID for every review, then I can know who's the user who made that particular review. But if I'd like to display all the users' information in one query, that wouldn't be possible because there is no joint queries. So if I select all the reviews from the collection of review, I'm still missing the picture profile and the profile picture and the name and location of my users. So what's the solution then? If I want to do it in one query, the solution is to duplicate data. That seems not good because we said in relational databases, so we have a schema to avoid duplication. And so the solution now for NoSQL databases is to bring all the data that you need in one place, on one location. Why? Because it's going to be very fast to grab this information. So this is why in NoSQL database, when you design your data, like your collection, you have to think about your queries. It's query-based design. Okay, so it depends the type of queries you need. You're gonna design your collection and try to put all the data you need for the same location. Now, the problem with, so now I solve the problem. I can in one query grab all the reviews from one collection and get all my data on my web page. But if a user decides to change his profile picture, we can have inconsistent data. So data duplication can always lead to inconsistent data. So here, for example, if a user tries to change his profile picture, I have to apply this change for every review, okay? Otherwise, we're gonna have inconsistent information. So, and there is always a risk that we don't update it everywhere, and we have suddenly got inconsistent data in our database. But then why NoSQL database, they are so popular right now? If there is a problem with database with data and consistency, why they are so popular? The question, to answer this question, I have to ask you another question. How many times users are going to update their profile picture? Maybe once a year? And how many users are going to see my restaurant reviews? Maybe 10,000 a year? So if I think about it, it's have one update versus 10,000 reads or maybe more. So it seems like a good idea to optimize the case that happen 10,000 a year than the one that happens only once a year. So this is why NoSQL databases, they are so popular. Another reason now, NoSQL databases, they can scale horizontally and vertically. What that means. So if your database is hosted in the cloud, like Google Cloud, it's pretty much easy that they can add automatically more servers to your database, so it can grow automatically. Why? Because they are designed to be distributed on multiple machines. It's not like the table of relational database that should be stored on one machine only. And so this is why they can scale automatically. And in this example, I have a collection of users, collection of restaurant and reviews. So if there is no more space on the same server, they just expand and store the new restaurant or the new reviews on other machines. And it's very, very much easy. Now, if I go back to the limitations of relational database, we see that the NoSQL databases, they solve all these problems, okay? So when to consider a NoSQL database? If you have rapid data growth and scalability. So because these databases, they are very well designed to be distributed on multiple machines, so it's gonna be easy to migrate also on the cloud, okay? And the second one is that it's very good for concurrent performance because they are focusing on the performance and availability. Yes, I know they sacrifice some of the consistency, but it's make them just much better choice for high volume and concurrent users that try to do the same information at the same time. And if I go back to my previous example, if my number of users just keep growing, my system will scale automatically and my application continue running. There is no problem, no crashes. No, so now I'm gonna present the differences like a summary. What is a NoSQL database and a relational database? So for the first, the relational database, I said that they have a problem because of the limited data growth and scalability because they just scale vertically. And on the other side, they are rapid for data growth and scalability. So they are limited in concurrent performance because of the using the lock mechanisms. And for NoSQL database, they are very good for simultaneous access. Okay, there is no locks. Distributed in the relational database, data is distributed across multiple tables. In NoSQL database, data is merged and nested into few collections. In relational database, we have normalized schema, which is static data structure, very hard to modify. In NoSQL database, they are schema-less, so they are flexible for new data requirements. So relational databases are good for structured data only. On the other side, we have structured and unstructured. The relational database use joins, sequences, and foreign keys. In the other side, there is no joins, no sequences, no foreign keys. So no joins, so that make the speed of your query very good. The problem with the sequences, you have to do it yourself. It's possible, we can. If you want to use like what is a sequence? A sequence, it's an object in the database that allow me to generate unique primary key, and they are always incremented. So we can do that. We can create our own node on the NoSQL database, and we just always access to the same value, and we increment it next. So we can do that. So in the other side, so the relational database is very expensive hardware and maintenance costs. And in NoSQL database, if you move or migrate your database on the cloud, you can pay as you go. So if in the beginning your database is just using like a little storage, you pay for that storage. If it needs to scale, then you're gonna pay more. So you just pay as you need. And the only good points that I will give to relational database is that it ensures data consistency. Sorry, I have to mute. Okay. It ensures data consistency. But for the other side, for the NoSQL databases, developers, they must include that in their code. So when you get data from your database, you have to make sure this data is good, is accurate. This is why in the column-based database, they have the timestamp for every column to know what is the last update of that data. But we see we have a lot of positive point for NoSQL database, so it's the winner today over the relational database. Finally, there is another one. For relational database, they are using SQL language, which is a structured query language. It's a standard. You can use the same language with multiple databases. In NoSQL database, every database has her own way to query this data. For example, in Cassandra, they are using CQL, which is Cassandra query language. It's pretty similar to SQL, but it's appropriate to Cassandra. And most of the time, other databases are just based on requests. Okay, so like we're gonna do today, you will see they are database requests. So this is the only difference. Like if you are trying to use a NoSQL database, you have to learn that new request and that new language. Now, what is Firebase? So while developing an app, it's not easy. Okay, developing a very successful app, it's not easy. You have to make sure your application is it's gonna work on across multiple platforms like iOS, Android, mobile users, and you want to get a lot of users. Okay, so my app should be compatible with multiple platforms, and we should have multiple users, and that means we need a backend server that will scale automatically with my users. Now, Firebase, it's a platform, for developing mobile and web applications that is very popular right now. This year, there is 2.5 million applications. They are actively per month. They are using Firebase. Every month, we have 2.5 million applications, and they are very popular applications like Trivago or New York Times, Alibaba website. They are all using Firebase. Gameloft. Why Firebase? Because it offers multiple tools, multiple libraries for any language. It's for iOS, you have for Swift, Objective-C, Android, you have for JavaScript, Java, C++, Unity. It's special. They have libraries for Unity for gamers, Python, PHP, and C#. And this is what we're going to use today. So what is Firebase? It offers multiple tools for developers just to make their life easy. Okay, they offers authentication. Authentication, it's like built-in functionalities that help user authenticate securely and very easily. So I'm gonna explain this later. We have Cloud Firestore, which is NoSQL database document-based. We have Realtime Database, which is a key value database that we're gonna use today in our workshop. There is Cloud Functions, so it's possible that you're gonna write some functions and send them and execute them on the cloud. This is gonna increase your process power. A cloud storage, this is used to store huge documents. Let's say you have videos, you have big documents, and you need them in your application. Then you can store them on the cloud, and the cloud will give you just the URL, okay, the link to access to that file. And then you're gonna save that link into your database. And hosting, so it's possible also to host web applications. And the new component, Firebase ML, which is machine learning. You can power up your application using the machine learning algorithms that are ready to use. So you can develop an application with AI in 1 hour. So it's amazing. Real time. Let's talk about the database, real-time database. So it's perfect for applications that need to handle data in real time across multiple devices. The data is stored as a JSON object, and it's only intended for text, only for text. So the contents is only text, okay? And it's why? It's for fast response. It works even offline with cache data and synchronize when online. Let's say you're using an application that is using real-time database, and while you're making an order, let's say you want to make an order on your phone, you lost your connection. So your order is not lost. Once your connection is back, the order will be sent. Okay, so this is very good. This is a structure of the real-time database. So you'll see it's a tree-like structure where we have a parent node, and every parent node, that is, let's say we have a collection of messages. This is a chat application. And then I'm going to have a collection of messages, and every node, this is a parent node. And then every child will be one particular message, one single message. But every child has a unique ID. This unique ID that you see here, it's automatically created by real-time database. It's called push ID, but you can use your own ID if you want. Okay, and inside every node, it has a key value. So we have this is what we represent by columns and rows. So for the column name, we have a key name. Instead of having column text, we're gonna have here it's key text. And the good thing, this is a schema-less. So our nodes, they can have different key values pairs. And if you want to access, so if you want to extract or read or retrieve all the messages, you have just to give we're gonna do that in the lab. You're gonna just give the name of your node, and then you're gonna bring all the data. That's the problem with the relational, with this real-time database, because if you read all the nested nodes, when you read one particular node, this is gonna kind of slow down the system and limit its performance. And if you wanna read one particular node, you have to provide the full path. We start from the parent node until we get to the ID of that particular node that you want to read or retrieve. Cloud Firestore now. So it uses scalable NoSQL database, that is a cloud based, it's on the cloud, and it's a collection of JSON objects. So that contain sub-collections, and a document cannot contain another document. The maximum size of our document is 1 megabyte. Why? Just to speed up the speed, to increase the speed. It works also offline. So when cache data, with cache data, and it's going to be synchronized when you become online, it works nearly real time. Okay, even if it's not called real-time database, but it's nearly real time. And by the way, Cloud Firestore, it came after real-time database, because they found out that current database have some issue of performance, so they want to just keep their performance growing and growing. And because of the issues, because every time we read a node, we have to retrieve all the nested nodes. Because of that, they bring a new data structure for their database, and they called it Cloud Firestore. But right now you can use both of them. Both of them, they are available. So if we come back to our previous example, we're going to have in Cloud Firestore, we're going to have a collection of restaurants, and every restaurant can have a link on another collection of reviews. Okay, if we are using real time, that's gonna be nested nodes in the tree. But here, because we said the restaurant cannot, a document cannot contain another document, then in this case, it's just gonna have a link on all the reviews that are related to that restaurant. And of course, we still need to duplicate the data from the table users, but this is not a big deal, because we said the chances to update data it's very small, because over reading data. Now, if I compare Cloud Firestore and real-time database, in real-time database, when you retrieve data, some element in the tree, you automatically retrieve everything below it. This is why their performance, it's limited. So it's limited to 200,000 concrete connection at the same time, and they have 1,000 writes per second. This is the limit right now of real-time database. This is why we have Cloud Firestore. So in Cloud Firestore queries, they are shallow by default, which means that when you grab a document, you will not grab everything if you don't need it. So you just grab one document in a collection, and then if you need the sub collection, then you're gonna do it. But if you don't need them, there is no need to grab everything. So the Cloud Firestore scale automatically up to 1 million users at the same time, and 1 million connections at the same time, and 10,000 writes per second. And they are still working on that to improve the performance and grow again. Cloud storage. So I said that cloud storage is used to store. It's another component of Firebase where you can store huge files like images, videos, audios. And the good thing is that even if you lose a connection during the upload on the server, you will not lose your file. Once your connection is back, it's going to continue the upload. So it doesn't matter what speed you have, your data will be safely uploaded on the cloud. And it's going to be available for all the other applications. Firebase Authentication. This is amazing service that allow you to do easily the login process. Okay, so Firebase, it can manage and protect the data of your users during the login. So the users, they can identify using either custom login. You can do a custom, and they have some templates that you can use to customize it to your app, or you can do login with a third provider. Okay, and there is no code that you're gonna write on the server side. So instead of worrying about, oh, how I can encrypt my password, how I gonna make my login like secure, you don't want to worry about that now. All the logins, there are libraries, built-in functionalities, they are already on the cloud. Just you need to use them. That's it. You just call them in your application, super fast. But we have, I will show you when we do the practice, I will show you that you have to also enable which provider you want to use in your app. And it's going to be so easy. They have also another type of services. They call it crash to improve the application quality. So they offered services that help us for developing the apps. Now they are offering other, there is another kind of services to improve the quality of your application. So a crash analytics, it's used to test your applications to prevent the crashes. You have performance monitoring. I will show you an example where you can see the number of users that are accessing your app, how many users at what time they are using your app, and test lab, where you can test your application on devices that are hosted on the Google Cloud. So you don't need to worry about if the app gonna be work or not on one particular device. So for the performance monitoring, as I said, it's a free, unlimited analytic tools that help you to get insight on the app and the user engagement about your app. So it's going to give you all the statistics you need to know how your app is going. For the crashlytics and test lab. So as I said, you don't need now to stock hundreds of devices and try your app on every single device. So all these devices, they are hosted on the cloud, and you can easily, with a test lab, test your application on those devices to prevent crashes. And there is another collections of other services like cloud messages, Google Analytics, predictions, dynamic links, remote config. All this is to improve the user experience and to make you gain money. So by the end, we develop apps to gain money. So it's gonna improve the cloud. For example, with the cloud messaging, they can give notifications of ads. They manage when they're gonna show the ads of the user to the users, what kind of ads they're gonna show to that user, just to improve your money, your income from that application, and help you to grow your business. Now, I would like to end my presentation by a success story, which is inspiring story. It's the application ClassKick. So ClassKick is a remote learning platform that teachers can use to monitor their whole class in real time. Okay, and during the pandemic, okay, in last March, with the COVID-19, with many schools, like closure of many schools, these developers, they were thinking about how to restructure their app or adapt their app to to get all these new users. Okay, so in this app, the student, they can work either on their own, and they can have the feedback in real time from their teachers. They can have ask for help privately also. They can work together, so they can help each other. And the teacher can share multiple files with the student, like videos, images, voices. And the classic team they turned to Firebase with the beginning of the pandemic that forced many schools to close, and thousands of teachers and students, they are willing to find a good platform for learning. They just, in no time, they changed their app. They got all the help they need from the team of Firebase and all the support, and their application scaled like exponentially. Okay, they are using a real-time database, the one that we use today. Even if I said it has limited performance over Cloud Firestore, but it's still so good, and they are so happy with their success now. In conclusion, so before we start the lab, the Firebase, it brings together all Google products, cloud services across the lifecycle of your app under one platform. Through Firebase, you can quickly spin your app backend without managing infrastructure, or release your app with confidence with app monitoring, and boost engagement and rich analytics and experimentation capabilities. So with Firebase, it's a complete solution for any developer who wants to grow his app and make it successful. And in conclusion, Firebase, it offers two NoSQL databases. As I said, Realtime Database, it's the original database of Firebase. It's an efficient for low latency solution for mobile and web applications. But the scale, as I said, it's limited to 200,000 connections at the same time. Cloud Firestore is the newest database for mobile app, and also it works for web applications. It builds on the success of the real time, but it improves it to improve that scale limitation. So Cloud Firestore is richer, faster queries, and scales further than real-time database. So it can scale up to 1 million users or connections at the same time. Thank you for watching and listening. I hope that was good for you. And if you have any question, I'm here to have your questions before we start the lab. So any question? Yes, you can have a break now. Before we start the lab, you can have a break. Do you need the break? 10 minutes break?
Yes, please, just for water and
yeah,
the washroom.
yes, it's fine.
Then I can focus again. Thank you.
Yeah. So you have 10 minutes break. After the break, now we're gonna practice. We're gonna apply. We're gonna see how to connect a real-time database with C#. Okay, and I will show you also an overview of all Google Analytics or Google like all the other services like authentication, analytics, and so on. So I uploaded on Teams and their files 2 documents. The first one, it's a zip file. So this is a template of my app. Because I know maybe we are limited in time. This is why I already created the form with the buttons and the UI. You don't want to worry about that. We just focus now on the connection with database, okay? And the second file is how to create that database, but I will do it with you live, okay? But if I'm too fast and you cannot follow, you just go to step by step. You have the screenshot step by step, and you will be able to set up your environment. But we're gonna continue after the break. And if you have any question, I'm here to get it for you, to answer any question. And by the way, these are links of Firebase. So you have amazing Firebase channel on YouTube. you can follow. They have so many tutorials, so many explain every component. You have a Firebase Facebook account, Twitter account, and also for sure the web page. There is Firebase Summit, which is like kind of conference every year. They do it and they show what are the new functionalities or the new like new features of Firebase. They also do a lot of workshops live, so they can show you how to build an app with AI power just within 1 hour. In an hour, you're gonna get an AI app, or like for example, an application. I saw a workshop where they developed translator application, voice translator application in 1 hour with a mobile app. And thanks to the ML, the machine learning components. Okay, so I give you 10 minutes. We come back. I'm still here, but I'm waiting for you. Let me know when you are ready.
Eva?
Yeah?
Hello.
Hello.
Excellent.
Thank you.
My God. Excellent.
Thank you. I know I didn't go in deep, but at least it gives you an idea now. What is NoSQL?
Very
but
excellent.
with a lab, it's more interesting. The lab, you will see it. You will see it live. Like how fast is it? This real-time database.
Presentation, huh?
Thank you.
My God. It seems for me starting from Turing machine. Do you remember? Okay. Very excellent.
Thank you.
Maybe we will use this database sooner.
Oh, sure. Yeah. Now, Fires, especially with Firebase, because you have all the documentation you need. You have all the libraries for any language, any platform. So it's much easy to go to Firebase.
Is such as an object-oriented database?
Yeah, kind of.
Yes.
Yeah, kind of, because
it's collections and
collections of objects. Yeah,
yes.
we need to create an object or a class that has all the fields that we need in our JSON object. So in the workshop,
we don't need a schema. We don't need the schema.
No more schema. No.
Is such as object-oriented.
Yeah, exactly.
Yes.
It's in real time. It's scalable. And we don't need to worry about buying hardware, configuring, and, everything is done for you on the cloud. You pay as you go.
I am sure we will switch with this kind of
This is the
database.
dream life of developers.
Our school maybe will switch this to this kind of database.
Yeah, we can.
Why not?
Propose that in our courses. Why not?
Yes.
Great.
So
when I proposed this Firebase, I proposed this Firebase like 3 years ago to my students who were doing a mobile program because they were wishing developing the same app, mobile app in iOS and Android. And they were asking me, how can we use the same database from Android and iOS applications? So the same application on different devices, and they want to synchronize. They use the same database. And that time I told them, go look on Firebase. I see that Firebase is very it's across multi-platform. It's the same database. You can use it with multi-platform. You have libraries for any language you use. Mr. Zarug is already using Firebase with the Android course. So if you have Android course in your program, you will practice Firebase with mobile application with Android. Me today, I'm gonna use C# because it's a common language of everybody. Because for web applications, they are using a library of JavaScript. Okay, so
Yes.
you need some background React or Node.js or so, but C Sharp, it's a common language of everybody. It's easy for every, so this is why I gonna use it today. Thank you, Yukon. And you're gonna learn more from my workshop. Okay, so stay here, don't leave. The coming next is more important. What's coming next? It's so there is no question.
It was perfectly clear.
Oh, good. I did it in purpose. I talked about normalization in purpose for our
Yes.
students because I know they hate normalization. I know.
But
So this,
usually, Salima, usually when you start to build your database, you have to think third normal form. Skip the first. If you have to maintain a database that is already created, you have to check
no,
if
for
it's
sure.
respecting.
Before you start like writing your code and implementing, creating the tables, for sure it should be in the third normal form.
Yes.
But it cannot be in the third if you didn't,
Yes.
if it's not already in second and first. So it's like a process. You have to do it step by step.
Yes.
But for sure, we never create a database that is only in first normal form
You
or
have to
second normal
think,
form.
yeah. Third normal form.
Yeah, this is why it's hard to do such a schema that is perfect from the beginning. And this is why many developers, they need to iterate through this design and change it, which is not easy.
Yes.
Yeah,
Salima,
so
regarde,
please.
Pardon, Salima, regarde, il y
Oui.
a une question de Jonathan Romero.
Ah oui, j'ai pas
Un
vu.
peu en plus haut, regarde là, dans le chat.
Okay.
First
Please,
of
you
all,
can take the mic if you have a question. Now referring to what you said in part of the webinar.
Jonathan Romero. First of all, did you see the big one?
Okay. He said, now referring to what you said in part of the webinar, for beginners, it's difficult to handle databases. According to your extensive experience, what advice could you give to students who want to venture into the world of databases? How to start in this world after graduation?
Student who want to
And because I have seen that also are with extensive experience. For Jonathan, for sure. Thank you, Irina. Thank you. I'm not reading the chat. Thank you. So to answer your question, so beginners, first of all, we need to teach them the relational database. It's really important that they know what are relational databases, what is the queries, because it's simple. Okay, we have a standard language that we have to teach. It's simple to understand. And my advice for beginners: follow the rules of normalization when you design your database. Okay, and usually when I give this course, I start by one big table that has all the data. Okay, and I start applying the normalization rule. In this column, we have multiple values, so this is going to be extracted in a different table. For that part, another column, it has, for example, composed values. Let's say instead of having last name, first name, you have one big column name, then you split it into two different columns. So you start just following and applying the rules of a normalization. You're going to end up by having a good design. Good design doesn't mean it's perfect. So you might need to, if you forgot any information to put in your initial design, let's say you have a piece of data that you need to insert, and you forgot to include that in your first design, then for sure you need to alter your table. But if you're asking what is the best solution, I think this presentation show you that now it's the era of the NoSQL database. Everybody is moving to NoSQL database because of the scalability, the performance, and So if you want to start as beginners, try Firebase. This is why I'm gonna do a workshop on Firebase. It's easy because it's multi-platform. For any language that you want to apply, you have libraries, you have many tutorials, and yeah. So I don't know if it answers your question, Jonathan. No, I think it's 10 minutes is.
Yeah, thank you very much, Salima. Thanks
Yeah?
very much.
Is it answering your question?
Yes.
Now, if you want to know what is the best, is it MongoDB or Firebase? I told you, MongoDB, it focuses on consistency and partition, how I name it again, the partition tolerance. Okay, it means multiple machines, but it sacrifices the availability because it's impossible that one distributed system offers the three guarantees. Okay, the three have the three properties. So you have to pick which one is best for your app. What is more important for you? Consistency with the partition tolerance, which is scalability, or availability and scalability. For all relational databases, they don't have scalability. They have only availability with backups and mirroring, and they have different strategies for that. And they have consistency with their schema. Okay, the only NoSQL database that is close to relational database, this is the graph-based database, Neo4j. They have another version with Python, and it's very, very good performance, even if you have millions of nodes. Okay, so if you want to keep the relationship, just use that database. And you want the performance, use that database. But as I said, it doesn't use a distributed system. It doesn't have a tolerance partition. So we have 30 minutes. We have to start our lab. Please go to on Teams, download the files. There is 2 files. I can share my screen to show you. Screen number 1. Yes. So here under files, you have how to prepare workshop and the template. So for the file PDF, you have all the steps that we need to follow to prepare this workshop. So please download both of them. Okay, so you can select your files and you go to download. Where is download? Usually it's here up on the top. So you download the files. As I said, the PDF file, just to the same steps, we're going to do it together. It's just to guide you. And I forgot to mention that for this, you need a Gmail account. So you have to connect to your Gmail account to access to that Google Cloud. So I'm going to just download it. Actually, I don't need it because I have it. You need to download it. And when you download it, it's really important that you right click on your folder, you go to properties and you I have my folder locally on my machine, so I don't need to unlock it. But if you download it from Teams, you're going to have a checkbox. And I mentioned that in my PDF. Because Windows consider this file as risky file because it comes from internet. So this is why in the second part, I'm talking about how to, yes, here, as I said, when you right click on your file, you have to unlock before you extract. It's really, really important. So for me, it's already unlock. Then you have to extract it. That's going to be our template for C# that we're going to use for to connect with a real-time database. I'm gonna open it. And please don't write on chat. I can't see your messages not right now. Please, you take a mic anytime. Don't worry about disturbing me, or just take a mic and ask a question, or whatever you want. Or if I'm too fast, just take the mic, please. So in this project, I have a Windows application. Okay. You see, I already created everything because it takes time. We have 3 text boxes for ID, name, and phone. We have a clear these text boxes. Sorry. We have different buttons. I'm gonna explain what is the difference between the push and the set functionality. And same thing for the delete, update, and retrieve. We have here refresh button that's gonna show the data that is online. So the idea here, we're gonna fill up this text boxes. We can, to insert new data in our database, we either use push or set, and this gonna include it in our database. Okay, and you will see the result here in the data grid view. It will update automatically with the database. You will see it's gonna be real time, really too fast. So but before that, so can I start? Please let me know if you are ready to start, because we have already we have 30 minutes left. But since
good, I don't know the others, but for me it's good, Salima.
Okay. And Alex, can I have like extra time, like 10 minutes? If
I'm not the best person to tell you that, Jonathan and the INT members, please, can you answer me? I think yes, but
yes, because I see the next activity at 4:30.
It's okay, no problem.
Yes. No worries. You can have extra time, no problem.
Thank you, thank you. Yeah. Just to make sure when I write the code, I'm gonna take the time, but you will see it's so easy, really, really easy. There is no easier than that. It's very easy code, don't worry about that. But I gave you, as I said, this document. It just explains the steps that I'm gonna do now, okay? And just in case I'm too fast or you cannot follow, then you just gonna go and follow these steps. So first step, as I said, you have to sign in with your Gmail account. And then you click on this link. This is the console of Firebase, okay? console.firebase.google.com. And then we're going to create a new project on Firebase together. But please, you have to connect on Gmail first. So me, I created a new account for Tech Week. I hope I remember my password. I'm so bad with passwords. Tech Week, I think Salima.techweek. Okay. .gmail. Give me a minute. I'm gonna check. I don't remember my password. Sorry. I did a screenshot yesterday. What is it? Pictures, maybe. So please connect to your Gmail accounts. Good. I can't see it. Ah, it's here. Okay, Tech Week 2020. Yeah, I was thinking I'm missing something. So it's Tech Week 2020. Salima.techweek2020. Gmail.com. Oh, couldn't find it.
Changer le code to H. Tech.
Ah, merci, merci, merci. Je suis chanceuse, j'ai des assistants en ligne. Live, thank you, Irina. Maintenant, mon password. I hope it's gonna work. Yay. You'll see in no time, we'll create a real-time database. So once you're connected, you just open a new tab and you click on the link that I provide you, console.google.com, console.firebase, sorry, console.firebase.google.com. And this is the first page, okay? But just make sure you're connected before you click on here. Now I click on create projects. I give a name to my project, for example, phone book. And it's better that you don't put any space, because this is kind of, it's like the variable names in programming. We don't want to include spaces to make sure. So it should be one word. There is no space. You accept the terms and then next. Here for Google Analytics, because this is our first project, we don't need Google Analytics right now. So you can disable it. If you keep it, it's fine. It's not bad, but you can disable it. You don't need it. And then you create a project. And all these steps, they are in the PDF file. So okay, now the project is ready to use. I just click continue. And this is my dashboard. Okay, so you see here, we have authentication. So we're going to give you an overview before we start the app. And you see you have videos everywhere explaining everything. So it's amazing. I didn't see such a documented platform or language. It's really, they give a lot of information that you need. So in the authentication, if you go get started, you see here different providers, and they are all disabled. So, and I cannot use it with C#, but for Facebook, for mobile and web application, what you need, let's say you want to do authentication with Facebook, you just enable it. That's it. And you can add the library. So you see when you enable, you have some keys that you're gonna use every time I enable something. So this is a different one. For example, for Google, they give you the keys that you need to use for the authentication library. So today I don't talk about authentication because I don't have a mobile application, but this is how you can activate what type of provider you want to use for your app. You can do multiple providers. We have also Cloud Firestore, which is another database, document database. So here we can create a database. This is the real-time database that we're going to use today. We have the storage, we have hosting, functions on cloud functions, machine learnings, and for quality, we have crash analytics, performance. To do that, maybe I can start a demo project. Let me go back to Firebase. I go to demo project just to show you. So don't do that, just to show you the analytics. Why it doesn't, it's slow. My internet is slow. So this is like a demo, like just to give you an idea what do you have in every tool.
My internet today is not good as well.
Me too. I'm connected with a cable, but anyway, so you can see here the performance you see of hosting. This is the crash-free users. You can have multiple statistics. I can let you explore it on your own, but now I'm gonna go back to my project. So when I go to Firebase, my phone app is here. I select my app. I go to Realtime Database. I have to create Realtime Database. So you just click on the button Create. And here for creating, if you start in locked mode, be careful. This will not allow you to do any read or writes, okay? So we can start with a test mode, because I forgot to mention that in Firebase, we have some security rules that are defined for our database. For example, you see in locked mode, read and write, they are false, okay? If you start as a test mode, you will see here, you're gonna read until that date. It's gonna be open, okay? It stay open for 1 month until this date. After that, it's gonna be locked. You have 30 days. Why 30 days? Because they let you start at least connecting your database and using it and giving you time to configure the security rules, because we should configure them later. Usually we do this security, it's easy to configure the security rules if we have authentications, like, because I'm not using authentication today, I cannot do that. But as I said, we're gonna start in test mode, so it's gonna be open for read and write. Now this is our database. You see, we have only the main node and it's empty. I can now, in my application, now create a link with this database. To establish the connection, I need two variables or two keys. The first key is this one that is on the top, and this is called the base path, okay? So remember, this is base path that we need to copy it in our code. So you can copy it now, and then we go to our C# program. In the main form, before that, sorry, I have to, it's okay, I can copy the base path now, but you see here in this comments, I have to copy my base path inside. I cannot remove the comments right now because I need to install the extension or the library that allow me to do that connection, but I'm just trying to copy these values now. Now, if I go back to my database, so did you all copy this? So we need to copy it in our C# program in the base path. So this is the base path that is in the main form class. You have to copy it from the top of the database. Now, the second variable that we need, are you done? Let me know, please, if I can continue or wait.
Yeah, I'm done.
For me is good. I don't know the others. Please, guys.
Yeah, it's okay.
Okay, good.
Okay, good. So now, if you, the second key that we need, it's called authentication secrets. Okay, this key. This is what we need to establish the connection. And to find the authentication secret, you have to go next to the project overview here on the top, click on project settings, and under service accounts, you select service database secrets, and it's here. All these steps, they are in the PDF file. So if I'm going too fast, just please, so you see, this is my authentication secret. I just click on this icon to copy it, and then I go to my C# program. So this is all what I need to create the link of my database. So now I'm gonna install the library, okay? If you didn't copy it now, it's okay. We can do it later. So now we have to install the library. Are you done? Please let me know. I don't want to go too fast, but
Okay for
Done.
me.
done? Okay.
Yeah.
Yeah.
So to install the library, we have just to right click on the solution, and we go to manage NuGet packages for the solution. And then it's installed tab that is selected by default. You have to select browse and you write Firesharp. We have to look for Firesharp. This is the library for C#. And you need to select the second one, firesharp.serialization.jsonnet. This one. So if I select, I go on the next, the next part of my screen. I select the project. I want to apply it on both projects, and then I click install. So I'm going to repeat. I close it. I just repeat. Right click, manage nuggets. You select browse. You write Firesharp. You select the second one. You select your project and then click install. That's it. This is what you need to include. They're gonna ask you your confirmation. We say yes, okay, and that's it. Once you install the library, we're gonna remove the comments that are on the top of my class using library, that ones. So once I'm done, I go back on the top, I remove these comments. So I have to I would like to use firesharp.config. This is the library to establish the connection. Firesharp.interfaces. This is the library to send data to our real-time database. And there is firesharp.response. And this is a library to get the data from database or get the response, receive response from database. We have 3 libraries or sub-libraries in Firesharp. And you can also now remove the comment about the iFirebase config. So this is how we gonna create the connection. So we store our configuration settings of our database in that object. So we have authentication secret and the base path. And we bring those information from our Firebase database on the cloud. We have a variable iFirebase client. This represents the instance of our database. Okay. So this one we have to initialize it to establish the connection. This is the client who represent the connection with the database. If you are ready to start, let me know.
I'm ready.
You're ready?
Yes.
Okay. So to establish the connection, we have, because I created some methods here. I don't know if it's here. No. So in the form load, yeah, here. In the form load, so when the form is loaded, I want to create a connection with a database. And if the connection is successful, I would like to just do a pop-up of a message box to tell me that the connection is good. Okay, so in the form load, we have to create or initialize our clients, which is here, that client. We're going to do this. We're going to do try catch first, just in case. And instead of, if we have a catch message box dot show, I'm going to see connection failed. And in the try, I will try to initialize my client, this dot client, which is iFirebase client, equal new Firesharp dot Firebase client. Firebase client is here. Okay. And we provide the configuration files, the configuration object that we created with authentication secret and the base path, we provide it to our client. That's it. In one line, I create the connection with my database. Now I'm gonna just check if my connection is not null. If my client this dot clients not equal to null, then I'm gonna do message box of dot show, and here I'm gonna say you are connected. Oh, sorry, connection successful, or connection is open. Let's try it now. That's it. This is all what we need. So first, you install the libraries, okay, with the nuggets. Second, you bring the credentials from your database. You copy the authentication secret and base path. And third, you create this of which is called client Firebase, and using that config object. So here we did it in the form load. In one line, we are instantiating our object. If it's not null, I'm gonna say the connection is open. If there is any kind of error, it's gonna catch. And now that's it. This is all what we need. We can run it. We see if the connection is established. Now the connection is open. So now we're gonna start by doing the first. So you see now in my database, I don't have time. Maybe you just follow and then I send you the solution probably. Maybe it's a good idea because I can send you the solution. I have it. So let's do the set now. Now, what's the difference between set and push? There are two different methods that allow me to send the data to database. The difference is that when you do set, you're gonna provide the ID. You have to provide the path of your node. Remember, we need the path of our node, and you have to the ID that you provide in the path. It's gonna be you generated. It's like you are creating your own ID. If you use push instead of set, then the ID that we saw on the slide, the push ID, will be generated automatically and will be the ID of your node. So it's better to use the push, I guess, because it's hard to make sure that our ID is unique. Okay, the push, it's unique and it's generated by Firebase, it's better, but I will do both. So let's take the first one. So I'm already getting the data from my text boxes. I create an object contact. So because we have JSON object, so we need to create a class that has all the fields we need for JSON object. But if you think that, for example, the phone is not important, it's gonna be null value, then in this case, your node will have only name and ID. Okay, so I'm gonna create a class that has all the fields that I may need, but when I create an object from that class, I don't need to initialize everything. So if I keep some fields null, then they will not be created as key value pairs in my node. So the node will not have these values. So I have already the class contact here. Here I'm reading the text box values. I'm creating an object. All what I need to insert data. To do that, I need to create a Firebase response. Okay. Equal. So it's a response object. Oops, sorry. And this Firebase response, it's asynchronous mode. And because it's a method that's going to work in asynchronous mode, you have to add async keyword in the top before every void. So every method that has this asynchronous mode, it should have this async keyword. Okay, so I put async and then I put await. And then I'm going to call my function, which is client, my client object. This dot client dot set. This is the click on set. So I'm gonna use set task, set asynchronous mode. Okay, and in the set we have to provide the path of our node. So I'm gonna set a new node under the collection that is called contacts. So even if this collection do not exist now in my database, it will be created. Okay, contacts. And we do slash because this is how to show it's a collection. Set asynchronous task, and then we need a value. So here we need the ID as the node value, the ID, and the value of the data that I want to insert, it's going to be this object data. That's it. This is what all I need. One line of code. I'm inserting, submitting a request to database to get that data. Now I can get the response. So this is contact result. So when I get the response from that, I'm gonna put response dot result as, and I specify that I want to get the result as an object contact. That's it. 2 lines, you're gonna get your response. So if you want to display the ID of, like, the confirmation of the object that was inserted into database. So this is all what you need. Now, if you want to refresh data grid view, we're gonna do it after. Now, so I'm gonna do execute that just to show you. Open the console at the same time. So for now, I'm not, so connection is open, that's fine. I'm gonna open my console, real-time database. So you see now my real-time database is empty. When I insert a new data, let's say ID1, put my name, any value for the phone, I click set, and instantly we have a new contact, a new node that is created under contacts. Okay, and this is the method set. If you do set, you have to provide the node ID, and this is what I'm using as ID field for my object. But as I said, it's not a good idea. It's better to use a push, because with a push method, the ID will be generated by Firebase. Now let's do the push, the button push. So same thing here. I have to, I can even copy these 2 lines. It's here. Firebase response, it's gonna be exactly the same in the push button. So I already get in the data from my text boxes. Because I have a wait keyword, I need to put async keyword before the void. This is the modification you need. And here, instead of set, I'm gonna call push. Push task, asynchronous mode. In push, you don't need to provide the ID under the collection, because it's gonna be generated. But all what you need is just to pass the data. That's it. We execute now. You see you have 2 lines of code. To insert new row, I just execute. Connection is open. Oops, sorry, I put a line here. How we can hide this? Okay, now I can insert ID2 with the name, I don't know, Lara, any number, push, and you see, it's very, very real-time database. We have a new node that is created. We have the ID of the node, which is the push ID generated by Firebase, and we have all the data we need. Let's insert another one without phone. Okay, I'm gonna insert another one, but the problem is here there is no rule that said that the field ID of your object JSON should be unique. If you want to make sure it's unique, you have to do some code to generate the sequence and update the sequence in the database. Okay, so this is why I said that developers should ensure the consistency of their data. So here I'm gonna insert another one with no phone. I have another, you see another object here. Because it's reading the content of, yeah, I'm gonna create, because I'm reading the content of the text box. This is why it's considered as empty string. But if I provide, let's say, here when I create instead of phone, I'm gonna just put null value, just to show you the example. I just create an object contact with ID name with no phone, and I execute. So I have just ID 22, name, push, or set. You can do set also. You see here, I have a new node, and what I have, only ID and name. This is why I said it's schema-less. You don't need your nodes. They don't have exactly the same structure or the same key values pair. Okay. Now let's continue. I'm sorry for the overtime. I didn't calculate the break. That's why. I'm sorry. So now we're gonna do the delete, for example. Here, I want to delete the child with that specific ID. That's simple. I say same thing. We're gonna create Firebase response. I can copy it from the set, but in the delete we have one line of code instead of two. We have one. So I don't need a response, okay? And you have this red line because you are missing async. I will send you the full solution, so you can just follow me just to understand, and I will send you the full solution. I'm sorry. So here you see, because of the await, I need the async, and here instead of set, I'm gonna call delete. That's it. It's a delete task that is asynchronous mode. In delete, we don't need an object data. All what we need is to specify which node we want to delete. So let's run this up, and we have one node with ID, because be careful, as I said, there are two types of deletes. There is a delete that give an ID. So the ID that I provide here, it's the ID of the node. And there is another way of delete it with a push ID, where I have to search that ID in my collection, find the push ID of that node, and then delete that particular node. So I go back, I see here I have one node that has ID 1. If I put 1, just I need ID, I click delete, and you will see it's gonna disappear. You see, my node is deleted from my database. Same thing for updates. 2 lines of code and you're gonna update. I'm gonna copy this the response again. I just changed the method call. So here it's gonna be update task dot update. And because this is an update with an ID, I have to provide the data objects. So it's gonna search that ID node and update the data, all the content of the node with that new object. I have async already, so that's good. I can get the response if you want, but it's not required. If you want to get a confirmation of what data was updated, you can get the response. So it's like here, we did response dot result as. We converted into from JSON into our class to see the values that were stored in database. But if you don't need that confirmation, just do it in one line of code. So let's do it now. Connection open. Okay, so I go back to my real-time database. Sorry, I need to insert something first because I don't have a node with an ID. I have a node only with push, and this is a different way. Okay, so Salima again. So it creates a node. Now I'm gonna use the same node, but I change to Sarah and I put different values. Now I click updates, and you see, it's too fast, very, very fast. That's it. I'm sorry I'm going fast, but I will send you the full code as I'm telling you. Retrieve now. If we want to get the data with one specific ID, same thing. The only thing here, as I'm telling you, always to access one particular node, you have to get the full path. So here I just don't need data, I just need the full path, which is our collection contacts followed by the ID of that node. I copy the keyword, and instead of updates, this is gonna be get asynchronous task. That's it. But however, when I get it here, I want to display what I get. So this is why in this case, I need to do contact objects, let's say data equal response dot result as a contact. And I'm gonna display this data object in my text boxes. So I can copy this. Sorry, don't do that. I'm allowed because I don't have time. So I just gonna copy to have these text boxes. And here, this will be data.id. This is data.name. And this is data.phone. That's it. Let's do it. Okay. So I'm gonna just check in database which ID I have. I have ID 1. So if I say 1, I did retrieve. I have the data in my text boxes. So you see, so easy to read, 2 lines of code. It's amazing. Now we're gonna do with the push. The push, so we did the inserts. Now a push with the deletes. So in this case, I have to find the child first, okay, having that particular ID, and then I'm gonna get that push ID. And once I have the push ID, I can execute one request of delete for that particular. So all the thing that changed is the ID, because I don't know what is the ID. So I'm gonna execute exactly the same function like this, delete. Sorry, I have to go back here, click here. So I'm gonna do that, okay? But here, instead of ID, I need a variable push ID. And that push ID, I have to find it for that particular object. So now I just write it now here, push ID, it's string. Sorry, it's a string. We have error because of async keyword that we have to add. That's it. But as I said, this one, I have to move it. It's not the same variable. Maybe because it's not initialized. Yeah, because I'm gonna initialize it once I find the node. So I'm gonna move this code when I find the node. So to do that, I have to retrieve all the nodes under the contacts collection. And when I retrieve all the nodes, this is gonna be a data structure dictionary. I'm gonna do for each loop over, I'm gonna go through all the elements of that dictionary, and I find the element having that particular ID value. Once I have that node, I can get the key of that dictionary. Okay, so the key is the key of the node in the dictionary. That's it. Once I have the key of the node, this is my push ID, and execute this line of code. It's gonna delete my same process. I have to do it for the update and for yeah. So now to do that, I'm gonna retrieve everything. So it's gonna be a get. I can copy this. So now we have to find the child and their contacts. So here we have to do get task. Okay. This will be delete. This will be get response. So I retrieve everything under this, and then I'm gonna get the results. So I'm gonna have Firebase. I'm gonna have a dictionary. Yes, sorry. Dictionary of the key is always a string, and the value will be contact object. So my dictionary is the results. Oh, sorry. result of my get response. So get response dot result as, same thing, but as what? As dictionary. I know because I'm retrieving everything. I know that the result will not be one node object, will be a dictionary of objects. That's it. Now I have my dictionary. I'm gonna just go through these elements for each loop. Objects. So I can put var in my dictionary. Var, I gave a name, object, for example. Elements, maybe element is good. In my dictionary, what I'm gonna do? I'm gonna check the key. If element dot key, sorry, dot ID, dot values, the value dot, the value of my element is an object, contacts, and that contact has a field ID. So if element dot value dot ID equals the ID that is here, okay, that I read from text box, then I gonna, it means my item is found. I gonna get his key. His key is my push ID. Then I gonna move these 2 lines of code inside. I gonna say that my push ID is elements dot key. Okay, the key of my element is a push ID, and with push ID I can delete that particular node. That's it. So this is how we do it. Since we don't have the we don't know what is the value. So I'm gonna execute this, and maybe I'm gonna just show you now the solution for the other functions. So I'm gonna open my database at the same time. Let's say ID2. ID2, it's not a node. So we have a push ID, or I can take 22. It's a push ID. Then I'm gonna put in my text box 22. I do delete push ID. Oh, it found it. It deleted. Too simple, too easy. So same thing, we can do it with the updates. Just the requests that change. Okay, it's the same code. You can copy it for update, but here instead of delete, you're gonna execute update. That's it. Now I can show you the full solution. It's better because since we have just 15 minutes now for the next presentation, I'm sorry for that. I didn't calculate the break, sorry, but I have the solution. It's ready. I can show you and share it with you on Teams so you can go through the code. That is not hard to understand, really not hard. However, I have to put my credentials of database here because when I made it, this one, I made it with another database with my Gmail account. So I have just to copy the credentials from my current Firebase. So I go back to Firebase database. So this link, as I said, is the base path that I have to copy here. And so this is what you need to change, okay? If you want to check this code at home, you have to update these credentials according to your project. I go project settings, account settings, database secrets, and I have the key here that I copy. So this is authentication secret here. So this is what you need to update before you execute my code. And that's it. Now I run it. I open my Firebase database. You see? So connection is open. Now I'm going to insert values. I can put another name, Salima. It's fine. And I do push. And you see, now I'm in this code, you have also how to refresh your data grid view. It's gonna read all the data that is in database and update it in data grid view. I can do, for example, updates with a push. So here, just the message box is slowing it's slowing down the display, but you see here it's updated like very fast. What do you want to do? Retrieve, for example. Let's do retrieve with ID 100. I put ID 100. I do retrieve with push ID. I have to remove that. So you see the data is here. Yeah, you can this is for refresh, clear. So do you have any question? So this is my workshop. I'm sorry for the delay. I'm sorry. I hope it's clear for everybody. If you have any question. No?
I think everything is clear. Thank you very much, Salima, for your presentation. Really good, and for the workshop. I hope everybody had enjoyed it.
I'm very happy for that. Thank you. I will share with you this code so you can read all the other functionalities. And as I told you, it's very easy. You have 2 lines of code and everything is done. There are, if you are interested, maybe we can organize in next semester other workshops like how to do authentication or how to do other types of. Thank you. And Mr. Zarug, I don't know if you have something with, since you're still you are using Firebase. Do you have some input to add or comments?
So hello everyone.
Hello.
And thank you, Salima, for your presentation, for your workshop. I appreciate your workshop. Everything is clear. Thank you very much.
Oh, thank you.
So
I didn't forget anything about Firebase.
No, I'm not.
Because you are using it, so maybe you forgot to mention something.
No, not necessarily forget something, but just we can say to student, this is for we start with, and after that the student can continue, because if even we teach a course 75 hours or 90 hours, we will be honest to students. We cannot teach you everything.
Exactly.
So you learn when you go to the market, when you go to the industry, you learn by doing the different projects. So this is the beginner. So keep going.
Exactly.
Thank you.
Thank you so much. So thank you everyone for coming to my workshop. I hope you enjoy it and you learned it. You discovered new technology, very easy to use. There are so many other functionalities that I couldn't present today, but it's really, really good to start NoSQL. Yes, Fode, thank you. Thank you so much. And,
thank you, everybody.
Thank you.
And a kind remind, we invite you all to the next to the next activity. So keep track of our Tech Week.
Okay.
Have a nice day, everybody.
Thank you. Have a nice day. So you have 10-minute break before the next next presentation of Tech Week. Thank you so much.
Bye, Salima. Good job.
Bye-bye. Thank you. Bye.
Bye.
Thank you, Salima. Bye.
You. I hope it was clear, Horia.
Very clear.
It's not too fast.
Perfectly clear.
Heureusement, j'ai prévu le template. Hein.
Heureusement.
Si j'ai pas créé le form, ce serait impossible de le faire, là, parce que c'est ça ce qui prend du temps.
Oui, le temps est passé trop vite.
Ouais.
Oui.
Mais
super intéressant.
Oui, c'est vraiment à explorer. Hein.
Oui.
It's very good to
et ça vaut le coup de l'utiliser. C'est tellement flexible.
Tellement facile aussi.
Oui.
Ouais.
Ça vaut le coup de l'utiliser.
So I will share now the solution with you on Teams, okay? And just don't forget to change the IP config, the IP config, the fire config, just the authentication secrets, and that's it. And you can use it for your database. So thank you so much, and enjoy Tech Week. Thank you.